Well, hello everyone. Welcome back. This is Mikhail Golovnya, Senior Advisory Data Scientist at Minitab. And in this follow-up video, we continue our investigation of all the different uses of predictive analytics module within Minitab Solution Center. So in the prior video, I showed how to open the data set and build a simple cart model. In this video, we're going to expand our model and try to build a TreeNet model. Again, as the reminder, we are trying to predict the output in kilowatts of a solar power plant on an hourly basis based on various characteristics of the sun, temperature, weather, etc., etc. And we're using the entire annual cycle of records. So we built a cart model before, and we focused on a 21-node cart tree that gave us predictive accuracy of around 80%, close to that. So let's see if we can beat that. So we're going to go to Predictive Analytics module, and this time I will focus on TreeNet Regression. This is a regression problem, and it gets to be very interesting to see what TreeNet can do. Again, the setup is very simple. We are trying to predict power output in kilowatts. We're using available continuous variables except for time as predictors. And there's also wind direction as a categorical predictor. For the TreeNet model, again, we will focus on using validation at about 30% randomly set aside as a test set. We are going to optimize least squared error. We'll build 300 trees. Each tree will have 6 nodes. I'm going to increase this limit to 10, so we'll allow at least 10 cases per node. And usually one of the learn rates that I normally use, I start at about a learn rate of 0.1, which is about 10%. Later on, you can increase number of trees, decrease learn rate, or play around with all of those parameters in many different ways. Okay, so that's about it. You just set up very simple things here. What I also recommend on the graphs, I usually increase one predictor partial dependence plots to cover all of the inputs that I have. So let's say I'll put 20 to be exhaustive. And for 2 predictor partial dependency, 2 is usually good enough because it shows 2 top most important variables, but you can also play around with that number, or you can generate these plots later on once the model has been built. That's really it. You just say, okay, and let's see how far we can reach with TreeNet in this case. We got our TreeNet regression, so I'm going to remove this pane here. I'm going to switch to model output here. So this way we have a lot more real estate on the screen. So it shows us general parameters for this model. It shows us the history of model performance on train and test samples. As you can see, our test sample goes pretty much up to 89%. That's a 10% boost over our best cart tree that we had before. So that's the power of TreeNet. TreeNet usually outperforms a single tree by the sheer nature of boosting approach. And as you can see, we have decent agreements between train and test. TreeNet picked sun elevation, cloud cover, sun direction, all of these variables as inputs. And the most important thing in TreeNet is that it also gives us plots, so we can actually get the general feel for what is going on in our model. Like, for example, in this case, sun elevation clearly, once it goes above 15 degrees in the sky, there's a significant progressive impact in terms of power generation in kilowatts. Those are kind of average contributions. As you can see, the scale goes rather dramatically here. With the cloud cover, about a third of the sky, up until the third is covered, there's not much impact, and then we can start exhibiting a certain drop in power output in several hundred kilowatts and so on. When you look at sun direction, obviously southern direction, and also depending on the actual physical orientation of solar panels in this solar power plant, it clearly shows the areas where we have maximization of that output. Wind direction, even though it shows some pattern here, it's really difficult to make any real sense out of it because that scale here is not as significant. As far as precipitation, pressure, and other variables, this is where we quickly losing some of that power of the magnitude of the contributions, and we can even rebuild the model by potentially eliminating a lot of these lesser variables that were reported here at the bottom of this relative variable importance list. So again, as you can see, very easy to generate the model. We fed all these different variables available. It naturally identified sun elevation, cloud cover, and sun direction as probably the most important variables, and we confirmed the actual natures of those relationships here on the plots. We achieved a very high level of predictive accuracy. This is close to 89% on the test sample, and as you can see, it kind of leveled off at this point. And in other words, within only a few minutes, I was able to crack the actual underlying dependencies in a very easy and informative way. And that's the beauty of TreeNet. What I usually recommend, you start with CART to get the general feel for what's going on, to find some basic rules, basic like kind of general features of the story. CART will not give you the most accurate model, but it will give you a lot of things to look at and to contemplate. And then you follow up with TreeNet, just the way I did it here. And in TreeNet, the main advantage is that you're getting superior performance almost universally. And you get access to these plots that provide an alternative, a more detailed engineering style view on what you can, how you can understand the nature of the problem. Now, in some other videos, we can talk about how to tune hyperparameters, how to do these other things, how to make predictions or do response optimizer. I will leave it for other videos. And by the way, the 3D plots over here, you can actually see I only requested one plot. I could easily request more plots if I go there, so I'll leave it for you to experiment. But on these bivariate plots, you can clearly see that as a cloud cover increases, there's a general drop in power output by all those marginal averages. But even more important is the sun elevation in the sky. So again, very simple, trivial example, quite intuitive. You don't need to have any specific domain expertise, but it can be easily generalized into all kinds of industrial and non-industrial applications out there. Well, hope you enjoyed it. Thank you very much. This is Mikhail Golovnya, Senior Advisory Data Scientist, Minitab.